Hello everyone, welcome back to MindSpread. This video continues on from the previous video on properties of sets. That video is linked in the description, so check it out if you haven't watched it already. In that video I've also left timestamps in the video description, so you can skip to the parts that you need. Okay, now for this video. This video focuses on remembering the rules of the last video and finding easy ways to remember all of those rules, because there's quite a few rules from the last video. Okay, before we do that, let's just recap unions and intersects. If I had a set A, and the set A has elements 1, 2, 3, 4 inside, and also have set B with elements 2, 3, -1 and -6. The symbol that looks like a U is known as the union, and the way I like to think about it is that it unifies everything. So A union B means all the elements of A and all elements of B. So that would be 1, 2, 3, 4, -1, -6, 2 and 3. But also remember, repeated elements in a set are treated like single elements. So repeated numbers such as 2 and 3 are treated like single elements instead, and only mentioned once in the brackets. Again, that's because a set is a well-defined collection of objects, and that doesn't matter whether something's repeated or not, it's still well-defined. The symbol for intersect looks like an N, and it's concerned with the elements that are common between A and B. The elements that are common between A and B is the numbers 2 and the numbers 3. Therefore, A intersect B would be elements 2 and 3. Okay, that's all you need to apply the properties of sets. So let's remember the properties of sets. In the last video, we discussed the acronym CADI, which stands for commutative, associative, dissociative, and idempotent properties. Let's find ways to remember those rules easily. It's important to realize that each of the letters has two rules associated with them, one for the union and one for the intersect. Let's start with the letter C for the commutative property, which is highlighted as white. For the union, A union with B is the same thing as B union with A, so the order doesn't matter. And for the second rule, which is now for the intersect, A intersect with B is the same thing as B intersect with A. The way I remember this rule is in the name commutative. The sets commute from A to B to B to A. The second letter highlighted in blue is the associative property. The way I remember this rule is if A union bracket B union C, if you move the bracket to the left, that will become A union B union C. And the same sort of rule applies for the intersect. Okay, so the letter in orange is a distributive property. This rule is slightly difficult to remember, but I think I found an easier way to remember it. So the rule goes like this. A is union with bracket B intersects C, which is then equal to bracket A union B intersected with bracket A union C. How do we remember this rule? Well, the trick is to keep it as simple as possible. So if you move that bracket to the left, it will look like A union B, which is the first part of the answer. Then if you look at the union sign right beside the letter A, if you flip that around, that'll look like an intersect. So now you got A union B intersect. Then all you got to do is basically union A and C together, and that's it. So just focus on the union symbol right to the right of capital A. So let's try this for the bottom rule to see how it works. A intersect B union C is equal to A intersect B union with A intersect C. How do we do this? Move the bracket to the left, you have A intersect B. Flip that intersect upside down, it becomes a union. And then with the same intersect symbol, now do it with C, so A intersect C. So altogether you'd have move the bracket to the left, A intersect B, flip that intersect around, it becomes a union. And then finally, A intersect C again. And that rule applies again to the top bracket as well. Move the bracket to the left, A union B, flip that union around, intersect. So A union B intersect with, and then finally A union C. Hope that helped. The last letter stands for the idempotent property. How do I remember it? Well, idempotent almost sounds like idiot. And you'd have to be an idiot to forget those two rules because they're quite simple. A union with A is A, and A intersect with A is A. Again, remember, each of these properties have a rule for the union and the rule for the intersect. Okay, last three letters, which stand for the University College of MindSpread. Actually, the acronym stands for Universal Sets, Complement Sets, and Empty Sets. So let's cover Universal Sets first. All of these acronyms are going to have a rule for the union and intersect. So for the Universal Set, A being union with the Universal Set is just the Universal Set, because the Universal Set contains A inside along with all the other sets. So if you're counting A with all of the other sets, you just got everything inside, which is Universal Set. A intersect the Universal Set is all the elements that are common between A and the Universal Set. The only elements that are going to be common between the universal set and A is A itself. Next one is the complement set. Complement set has the most rules in it. So here's how I like to remember it. I just remember there's 7 rules altogether. Some people say 777 is the number for angels or something like that. Anyway, there's 2 rules for the union and intersect, just like every other rule that's been made. There's 2 for De Morgan, and how we remember De Morgan's law is that in our last video we proved De Morgan's law. So, we proved it. We must remember it. Otherwise, it's like raising a child and forgetting its name. It just can't happen. And the last 3 are basically definitions of when you're using the complement. So let's cover them all. Starting with the 3 definitions. The complement of A is all the elements that are not A. So the complement of A is A itself, because it's all the elements that are not A. The complement of a universal set is the empty set, which is given that symbol phi, and the complement of an empty set is the universal set. Now for De Morgan's law. We proved that in the last video, so what was it? It was the complement of A union B is equal to the complement of A intersected with the complement of B. And the other De Morgan's law is complement of A intersect B is equal to the complement of A union with the complement of B. And the last 2 rules are for, unions and intersects in general. A union with the complement of A is the universal set, because all the elements that are A and all the elements that are not A are in the universal set. And A intersect the complement of A is the empty set, because the only elements in common between A and not A is basically there are no elements, so we call that the empty set. Finally, the empty set. Basically, the empty set union with A is A, and the empty set intersected with A is the empty set. Again, remember, each of these rules have 1 rule for the union and 1 rule for the intersect. I'm emphasizing on that point specifically. The complement was an exception because it has not only the union and intersect rules, but the De Morgan's law and also those 3 definitions. In summation, all 7 rules. Okay, that's all of the rules. Don't forget to test yourself and challenge yourself. See if you can actually remember them off by heart. Don't forget to subscribe. Take care.